This is problem number 6 from section 3.3. In this problem it says find the derivative of the function, and they give you y equals 5t minus 1 times 6t minus 4 to the negative 1 power. Now we have a way to take the derivative of this function using the product rule, but the problem is we have this negative 1 for a power up here. So we'd actually have to use a rule called the chain rule that we haven't talked about yet. So the product rule is kind of out for this problem right now, but we know we have a negative 1 for an exponent. That means we can actually write this as a fraction. So we can write this as y equals 5t minus 1 times 1 over 6t minus 4. So then I can actually write that as 5t minus 1 when I multiply over 6t minus 4. So I'm going to take the derivative now, and when I take this derivative I always start u equals the top one, v is the bottom one. So u prime, v prime. U is 5t minus 1. V is 6t minus 4. When I take the derivative of the top, I end up with 5 for the first part, and this is 0, so I just end up with 5 there. When I take the derivative of the bottom, I get 6, and the derivative of negative 4 is 0. So I end up with 5 and 6 for my derivatives. So now I'm going to use the quotient rule, and that's u prime, so u prime is 5, times v, which is 6t minus 4. By the way, I'm going to write dy over d, this would be dt because our independent variable is t, equals 5 times 6t minus 4 minus 6 times u, which is 5t minus 1, all over, I'll get v squared on the bottom, which is 6t minus 4 squared. When I do some distributing, I end up with 30t minus 20 minus 30t plus 6 all over 6t minus 4 squared. So I end up with, when I combine some like terms together, this cancels. I'm left with negative 20 plus 6, which is negative 14, over 6t minus 4 squared, and that's as far as we can go with this problem. This is a simplified version. I just want to point out the calculus part of this happened right here. When I took the derivative, when I used the quotient rule, that was a calculus part. After the calculus part, then it's just simplifying. This is the derivative of y with respect to t.